Hello, my name is Zane White, and I am an environmental geoscience and geomatics student going into my fourth year at the University of Guelph. When analyzing the world we live in, geomatics scientists often use Geographical Information Systems, GIS, and its many applications. These GIS allow for the manipulation and interpretation of various satellite and other remotely sensed imagery. Specific to my research this summer, Dr. Ben DeVries and I focused on the applications of digital elevation models, or DEMs for short. These models are extremely versatile and may be utilized in various applications as they represent the elevation of a given area. Fundamental to hydrological studies, we can use these digital elevation models to understand and predict how water will flow over a terrain as gravity is the driving force. For my research this summer, the intended goal is to generate watersheds over the North and South Carolina landscape, developing regions that can be used for future flood analysis. These watersheds, as seen on the lower left poster image, represent a region such that if a theoretical raindrop were to land on any yellow pixel, it would eventually flow to the final drainage point indicated in green. Though many GIS software provides the tools necessary to generate these watersheds, there is a level of pre-processing that may be done beforehand to ensure consistency in results. For example, a satellite image may see a bridge and a dam as the same object, as the view from above suggests full obstruction. However, most bridges over streams and rivers actually allow for water to flow through to the opposite side. As one may suspect, this small feature has the potential to cause drastic changes to the resulting watershed if left unresolved. To pre-process a digital elevation model is to conduct research and modify existing data that the computer would otherwise see as completely valid. Among many different techniques, I've chosen 3 important processing tools and strategies that were used throughout the summer. The first tool is a method that will fill any sink in a region. Sinks can be identified by regions of low elevation that have no distinct outlet or path for water to escape. A common use of this tool is for quarries to essentially be removed from affecting the resulting flow in the region by raising its elevation to that of the surrounding area. One may think of this region as being similar to a lake, however many quarries are blocked off from streams which the satellite imagery may not pick up on and thus requires manual processing to fix. The second method is often known as stream burning, where the main line for any river or stream is manually dropped on the software to a significantly lower elevation value. This modification, although unnatural, ensures that the flow along the stream stays consistent. The final method being showcased is a breach. Using the example of roads and bridges that were discussed earlier, the breach allows for these features to be passed through in the digital model for the flow to continue unaffected. As can be seen by the few examples provided today, there are many decisions made behind the scenes when conducting research upon the world that we live in.